we're going to welcome Anna Weber onto the stage as our Chief Recruitment Officer.
What you see here are the microbes living in a single drop of water. Our world is full of them. They are in the air we breathe, in the food we eat, on every surface we touch. Most of them are completely harmless. They are friends and neighbors. But some are criminals and troublemakers. We call them pathogens. And pathos means suffering. So you see, the immune system has an almost impossibly hard task to protect our body from the millions of pathogens surrounding it, to be able to remember the pathogens it has fought before and mount a strong response against them, and to do all of that without harming our body in the fighting. That is why the immune system depends on the best police force in the world, the T-cell police. Welcome, everybody. Does that sound like an exciting, fast-paced work environment that you would like to join? Well, you are in luck. Welcome to your new job. Welcome to the T-cell police. I am so excited to welcome all of you here in our finest training camp. So glad to see that so many young T-cells have decided to apply for a job on the T-cell police. So let me introduce how we work here. You see, each and every one of you is already a specialist. You each have an individual weapon, the T-cell receptor. This is a protein that you carry on your cell surface and that you can use to very specifically bind to a certain pathogen to attack it. So that means that every T-cell is really good at recognizing one particular pathogen, but at the same time is completely blind towards all others. That is why we recruit millions of T-cells into our police force, each one with a different receptor responsible for a different pathogen. The greatest honor that you can achieve in the T-cell police is to recognize your pathogen with your receptor. Then we will make thousands of clones of you to fight off that pathogen. You will get a shiny medal and a place on the Council of Memory T-cells, so that we never forget how to effectively fight that pathogen again. So you see, glory awaits you in the T-cell police. Are you excited to start your training? Yeah, right. So that's what I imagine they tell the young T-cells on the first day of assignments to make them really motivated. By the way, have you heard of the thymus before? It's this little, almost heart-shaped organ at the base of the throat. It is the reason why T-cells are called T-cells, and it is the site of an incredibly hard obstacle course that all the young T-cells have to go through before they can become mature members of the T-cell police. Because you see, the trouble with having these specific T-cell receptors is that your body doesn't actually know in advance which ones it is going to need. It's not as if your body has encountered all the pathogens before, and even if it had, there are so many of them, it will be impossible to save the blueprints for all of them. And as we've all learned during the coronavirus pandemic, these pathogens keep on changing all the time anyways. So, the young T-cells actually all build random receptors. And only the sheer number of T-cells will ensure that there is one with the correct receptor for each pathogen. Well, if the young T-cells all build random receptors, what does that mean for the T-cell police? Well, first of all, it means that even if you do get through training and you manage to graduate, your pathogen will likely never show up. And you will end up endlessly patrolling the boring corridors of blood vessels without ever getting any action. Well, boring life to say, but at least a safe job, right? Yeah, well, As usual, it's getting there that is the actual problem. Because you see, the body itself is full of proteins. And if a T cell has randomly created a receptor that can bind to one of those, we have a huge problem on our hands. What results is what we call an autoimmune disease, when the immune system starts attacking the body instead of protecting it. So, the immune system has to make sure this doesn't happen. And here is where the famous obstacle course comes into play. Here, the young T cells have to test their random receptors and prove themselves worthy. First, there is a process called positive selection. Now, can you imagine what it looks like if a construction process is random? Yeah. Some of these cells are going to show up with absolutely useless receptors that aren't going to be binding to anything at all. So, in the first step of training, the T cells have to prove that their receptor is even functional. Secondly, and even more importantly, comes the process of negative selection. Here, the T cells have to test the receptor against every protein that is produced anywhere in the body. And if it turns out that the receptor binds to one of these body proteins, the T cell is kicked out. And I say kicked out to keep this all kids friendly. Well, I think you all know what that means. Yeah, so who's the ones to join the T cell police? Yeah, I wouldn't either, honestly. I'd rather do a Ph.D. even though that can be quite the obstacle course in its own right. In my Ph.D., I work with data from patients that have an autoimmune disease called vasculitis. For these vasculitis patients, the immune system attacks their blood vessels, which, depending on the blood vessel that's targeted, can mean that they have trouble moving certain muscles, can make them blind, destroy their kidneys, or worse. Diseases like that happen because despite this rigorous selection process in the thymus, from time to time, a T cell with a self-reactive receptor can slip through. And we've just known what happens then. So, as with many autoimmune diseases, for vasculitis, we don't precisely know which of these T cells cause the disease. And that prevents us from developing more targeted therapies. So, here's where I come into play. It is my job to find out which of the T cells are the traitors who cheated on the obstacle course. To do that, I dig deep into the data, looking for clues. I look for T cells that vasculitis patients share and healthy people lack. And I also take a very close look at that destroyed blood vessel tissue, the crime scene, if you will, to see which T cells we find there more often than we should. And finally, I try to connect all of the dots and find the characteristics of one of these suspicious T cells. So, in the end, I may not have joined the T cell police, but I guess I do detective work, after all.